10 to get 7.4 amps for my I total. So now I know there are 7.4 amps moving through every one of these resistors. And I can easily find out the drop on each one of those resistors. So my goal right now is to just find out what the terminal voltage is here. Notice I can do that two ways. I can, going back here, there's my V terminal there, but also my V terminal equals the sum of all the other V drops. So the V terminal 88, I'm just going to go after what seems to be the easiest way to do this, is going to be the 88 minus V1 ohm, which equals 88 minus I total, because the entire current goes through. Sorry. So V terminal 88 equals 88 minus V of the 1 ohm equals 88 then minus 7.4 I total, because it all goes through that 1 ohm, times that 1 ohm, and that equals 88, so oops, 81. Somebody get me a calculator. 81.6. 80.6. So there's the terminal voltage of this battery right here. It's 80.6. And now I'll go after the terminal voltage for the other battery. Now the terminal voltage for the other battery rests on the same loop. So I take the same equation, but this time, in order to solve for the terminal voltage of this battery, I need to have these two on one side and everything else on the other. So this is what that ends up looking like. Same equation now. I'll take the initial equation where I have the gain equaling the sum of all the drops. And I am looking to have now this and this alone on one side of the equation. The sum, or when I put these two together, I get the terminal voltage. I haven't created any new rule here. I've simply identified that the terminal voltage for this battery right here is equal to those two things inside the battery put together. They are both behaving as drops in the overall circuit. But for themselves, if I isolate them, I can see what that value ends up being. They need to be together to get the terminal voltage for this one. To get the terminal voltage on this one, I need to put those two together. So now going on to the second one then, isolating these two guys in this equation, which I'll just call then V term of 14 equals then these two guys together. I can't change any signs. I'm just going to leave them there, and I'm going to put everything else on the other side. So I'm going to have 88 minus that V drop, minus that V drop, minus that V drop. 88 minus V of the 1 ohm minus V of the 5 ohm minus V of the 2 ohm prime. That equals my V of my 2 ohm, which is inside the 14 volt, plus the 14 volts. Again, this is the terminal voltage I'm looking for in this case. I can, right at this point, I can recognize, well, that right there is I times the 2. So I've got total current going through there times 2 ohms plus 14, and I get an answer of 28.8 volts. So there's my answer. I would like you to notice that it's the same answer on the opposite side. 88 minus the voltage, which is total current, 7.4 amps times the 1, minus 7.4 times the 5, minus 7.4 times 2. This, in a simplified version, then, is 88 minus 7.4 times 1 plus 5 plus 2. So that's times 8. That's 3.2. That's 56, so 59.2, 88 minus 59.2 is 28.